Hello everyone. So today's topic is IoT, Internet of Things. The upgraded version is called IIoT, which is Industrial Internet of Things. Here things represents devices. Devices means like a CCTV camera or Alexa or Google Home, thermostat, kitchen appliances, even a car like an automobile. These all comes under the devices. These devices will be connected to a IP address, a particular IP address. For example, like we all get internet connections, right? Each and every internet connection will have a IP address. When these devices connect to that particular IP address, it will create a hub or a web, which is nothing but the internet of things, and we will be able to monitor and control it. Okay, so what makes the IoT connected devices and a motion activated devices a difference? So, for example, like there's a bulb in a corridor which is motion activated. So, if you travel or if you pass by that particular place, the bulb will automatically switch on. In same fashion, even for IoT connected devices, it will switch on. But there is one particular difference. It is the IoT activated devices will also carry data. With this IoT connected devices, when a sensor detects the motion and the actuator turns on the light, those actions are captured as data and sent to the data center or a server or a cloud, like any device which stores information for recording and analysis. And where there is data, there needs to be a IoT architecture. So here comes our hero, the main topic. So wherever these data are residing, there we have to fix a IoT architecture that tells us where the data has to be used, what format is to use, and what actions to take based on this data. So, in which departments we can use this IoT devices? It can be used in various departments like agriculture, healthcare, retail, sports, entertainment, even utilities, construction, building automation, education, airlines, and military. So, we can use in these areas. With a solid platform and a well designed architecture, IoT can improve safety, efficiency, and productivity in virtually in every industry. Like these are the major three reasons why we are deploying this IoT, which is safety, efficiency, and productivity. So now we will see the top five challenges across all stages of implementation. So, say, assume that you have a company and we are doing these things. So, what are the top five challenges? The first one is time to completion. So, you are already using a traditional method, and if you want to convert it into IoT completely, it will take a good time span. So, that is one thing. Second is limited internal expertise. So the employees will not be skilled with this new technology. They might have like little bit knowledge about it. So we need to get some outsourcing related to this. And then quality of data. This IoT device needs a lot of data, a lot of quality of data, which will give you the accurate information. That's the quality of data. The fourth one is integration across teams. For example, if it is like a large organization, like a computer industry, it will have different departments, right? Like it will have a marketing department, a production department, innovation department, HR department, financial department. So there are various departments, and they have to be on same page if we implement this IoT technology there. And then budget overruns. It's a complicated process. Investment will be high, so you need to invest a big amount. It might overrun. However, for a long period, it will give you multiple returns. So now we will check the advantages. So the advantages are, first one is huge cost saving in a long run. And then second is improves employees productivity. It will ease the life of employees. At the same time, the quality of work will be good. And then improving customers request and service delivery, which influence results in significant impact in customer experience. So customers will be happy with the instant service they get. And remember, a customer centric company grows rapidly. So if we check with the reference model as shown in that picture, the first stage shows physical devices and controllers. Physical devices we already discussed. That is nothing but the things which get connected to that IP network, like be it is a computer or a server, or like the bulb, or any electronic products which are connected to that IP address is called the physical devices. So those are deployed in the first stage. Second is connectivity. How you're going to connect it, whether it is Wi-Fi connection or a wired LAN connection, or whether it is like a two-way communication. So all will be designed in this connectivity stage. Then comes edge, in brackets it says fog computing. These are like two different technologies, but it does the same work. It pushes data and intelligence to the analytic platform to the next level. And next comes the data accumulation. So here it stores the information. Accumulation, so it accumulates the data. In this stage, feedback does not have to be immediate, so the data gets forwarded to the physical data center or the cloud based system, wherever you want to store the information. As I mentioned previously, here the um, IoT architecture will be placed. So where the IT people, the IT system, they analyze, manage, and securely store the data. So that process goes on here, and then comes data abstraction, which is nothing but scaling of data takes place here. Application stage, where interpretation occurs depending on the request, and then comes collaboration and process, depending on the type of software you have installed, whether it is related to temperature or monitoring a traffic. So those particular outcomes will be given here. So here the application executes business logic and to empower the people. So application gives business people the right data at right time so that they can do the right things. So this is about the reference model. So overall we have 7 stages. First we deploy, and then we connect it, and then we push the data to the next level. Here whatever information we gather, it will be analyzed, and all the important data will be stored here. Duplicate data will be removed, and then a data abstraction, application, and collaboration. For example, if you need only one particular data, it will be sent from this data accumulation. The other information will be stored safely for future purpose. So this is how the reference model will be. So the next one will be enterprise level of application. So we'll see how that works. So the flow chart we see here is reference architecture for enterprise IoT. So here we have 3 different stages: edge tier, platform tier, enterprise tier. By now you should have an idea like where what particular information, what particular device or what operation goes on there. For example, if we check the first stage, it is IoT device, where T means things, which is devices, which I already explained. All the hardwares will be deployed here, so the sensors will sense the information, and then the process will go on, and the end command will be given to the actuator, which will implement it. For example, like if you want to switch on the bulb, give the command, it will be sensed by the sensor, the process will go on, and then it will be, the command will be given to the actuator, which is like a PLC board, and it implements it. And then from there it goes to the IoT gateway. Between this, there is a connectivity. It might be like wired LAN connectivity or a Wi-Fi connectivity. And one more important information I want to add here is like I had this experience with my previous company when where I worked with. Our clients call back and they say they need some wire connectivity which will connect to the legacy ports. They are devices which works with Windows 7 operating system, and the softwares which that particular company works, it only supports Windows 7. It will not support Windows 10. And if they purchase a new machine, then it will have Windows 10, and that software may or may not be compatible. So instead of taking a risk there, some customers, I mean, some clients, what they do is they purchase a compatible wire, I mean, the cables, and then they connect it to the new technology, which are like the sensors we are connecting with. So in this way, the connectivity will goes on there. And then the next stage is IoT gateway. IoT gateway is about the technology we discussed earlier regarding edge computing and fog computing. Edge computing usually occurs directly on the devices to which sensors are attached. We say the gateway device close to the sensors, and the one which is next step will be fog computing. It moves the edge computing activities to processor that are connected to LAN, and then from there all these data will be flown to the IoT services, which is the data center. It will receive, process, forward information, I mean forward control commands from enterprise to the edge tier. In this stage, it consolidates, process and analysis data flow from the edge tier and provides management function for devices and assets. And the next stage will be the final stage, which is big data. I mean, these are the options given there, three types. One is like big data, and then BPM, and then government applications. So depending on the applications, it will be designed accordingly. Big data is one of the popular term. So big data deals with large diverse data sets that include structured, semi-structured, unstructured data from different resources and different size, like it might be in gigabytes or terabytes, so large informations. So that will be taken care over there. And one information I want to add is they will have years of data, like 4 to 5 years data will also be available in that big data. In that way, these are designed. So this is about the enterprise IoT. And one added information is regarding the sensors. It does not depend on the type of the device or the size of the device or the location where it is placed. Sensors, it's only major thing is like it should be connected to a IP, like a unique IP address network. So that is about the reference model for enterprise architecture. And then if we check with the modern architecture, it's again like a simple process, almost like same things. It involves infrastructure development, standardization, and then the matured IoT system. So overall, this is about the IoT technology. If you have any questions, leave a comment so that I can reply to those. Stay safe, strong, and have a good day. Cheers.